guys, welcome to the ExamRat. So let's just begin with our next unit, that is unit number 5, mensurations. It will basically include two chapters, that is chapter number 12 Herons Formula and chapter number 13 surface area and volume. And in today's session we will be going to have idea of both the chapters. Okay, so before beginning with that, let me tell you that please go through our website and subscribe, and for more such videos just link is in the description given below. Okay, so let's start with our next unit, that is unit number 5, mensurations. Let's begin with the first chapter, that is your Heron's Formula. Basically this is the very small and the easiest chapter of the mathematics, that is Heron's Formula. I know you people don't know that what is this Heron's Formula, and also this term will be something new for you. Okay, so basically this is a very new term for you people. And what is the Heron Formula? This is the formula which is used to calculate the area of the triangle. Right, this is what we called as the Heron's Formula. Now what is this Heron's Formula is, what are the variable means, and how this formula can be applied to different mathematic chapters, we can have just a look here. Okay, now our first slide is what is Heron's Formula and how it was discovered. Okay, so basically Heron's Formula, it was named after Hero of Alexandria, a Greek engineer and mathematician. Right, he is the person who basically gives the concept of the Heron's Formula, and that is why that is known as the Heron's Formula. You can use this formula to find out the area of triangle using 3 side length. Okay, now you only have to know the perimeter of triangle and side measurements. So what you get from this particular thing is Heron's Formula require no base, no height, nothing. It just require all the 3 sides and perimeter. Obviously when the sides are given, then you can calculate the perimeter by just adding those sides. Right, now what is this Heron's Formula? Heron's Formula is used to find out the area of any triangle. Now I like to explain you. Let's just suppose this is a quadrilateral, this is a diagonal. So basically this diagonal divide this quadrilateral into 2 triangles. So if we have to find out the area of the quadrilateral, we can just add, we can find out the area of the 2 triangles and add to get the area of this whole quadrilateral. This is just the need of Heron's Formula. You can find out the area of both triangle as well as the quadrilateral. Right, so basically the Heron's Formula is S minus A, S minus B multiplied by S minus C whole root. Right, so what is this S means, what is this ABC means? Let me tell you. S means perimeter of the triangle divided by 2, or you can write it as that let the sides of the triangle be A, B and C. So perimeter will be A plus B plus C, that is the sum of all sides. You know that perimeter of any figure is sum of all the sides divided by 2, that is your S. Right, and ABC are the length of the sides of the triangle. For example, let's just take the example like this is the length A, this is length B, this is length C. Then in that case S will be A plus B plus C, that will be the perimeter divided by 2. Right, and you just have to put these numerical values into this particular formula and you can easily get the area of the triangle. Right, so what is the perimeter and area of the triangle? You know that what is an area? Area is basically the area covered. Like this is the triangle, the area will be this shaded region of the triangle will be the area. Right, now if I say that what is the perimeter of the triangle, then this triangle's, this outer lining of this triangle will be known as the perimeter of the particular triangle. Not only of triangle, it could be of any particular shape, right? So what is this perimeter and areas formula? In the earlier classes we learned that perimeter of triangle is sum of all the sides, right? Similarly, the area of triangle is half into base into height of the triangle. Am I right? This is what we called as the area. So basically in this chapter we will learn to know the area of the triangle by just knowing the three sides. We don't have to calculate the height, we don't have to know the base, we just have to know the three sides, right? Now the need of Heron's formula. Basically the first need, I already told you that Heron's formula used to calculate the area of the triangles, either it be equilateral or it be isosceles or it could be scalene, right? Then it could also be used to find out the area of the quadrilateral. Like I told you that a quadrilateral, the diagonal of the quadrilateral basically divides the quadrilateral into two triangles. So by calculating the area of the triangle using Heron's formula, you can just add it to form the area of quadrilateral. Now these are some daily life examples of using this Heron's formula. When we buy a piece of land, we can find the area by using Heron's formula, because in the case of land, when we buy the land, we don't know about the height of the length, okay, we only know about the length, breadth and other sides, right? Imagine someone gave you a triangular figure, it can be 2D or 3D. Now you can find out this area by just applying the Heron's formula. This is very easy formula. You just have to know the value of each side and you just have to put as it is into the formula and you will get the Heron's formula and the area of triangle, right? So here look at some questions about the Heron's formula. Okay, so let me solve some questions for you people so you can have a better understanding, right? So first is the perimeter of the triangular field is 240 meters. The two sides are given. Let one side be A, let another side be B. Find the length of altitude on the side of 50-meter length from its opposite vertices. Now let's see. Perimeter is sum of the sides, right? So 240 meters will be equal to 78 plus 50 plus C meters. Am I right? Then C will be somewhere equals to 240 minus 128. Am I right? C will be like this only, right? Now we have to put this like C will be 112 meters, right? This will be the value of the C. You can just confirm it by adding all the terms, right? Okay, now this is the value of C. Now what we'll do is we have to find out the area of the triangle, and we know we have to find out basically the area of triangle using Heron's formula. So we'll put this area of triangle equals to this area of triangle, right? Now what we'll do, we know that base is 50 meters and we have to find out the height equals to root over. Now our next thing is to put on the values. What is the S? Calculate the S as A plus B plus C by 2. That will be 120 meters, right? Now 120 minus A. If we subtract 120 minus 78, then what we'll get is 42 meters. Oh, I'm sorry for that. Yeah, 42 meters. Then we'll subtract 120 then we'll subtract 50 from 120 and we'll get 70. Then we subtract this 112 from 120 and we'll get 8. This is in the whole root, right? Now 25 into h will be equals to root over what will be this so and so value. You just have to calculate this value, let it be x, and by this you can just easily calculate the value of the length of the altitude of the given triangular field. Okay, you basically, I have not calculated this whole thing here, so with x I meant this whole term. You just have to calculate it using calculators, but don't use calculators, like you are not that grown up that you should use calculators. Okay, so this is all about the Heron's formula. Only this type of questions will be there in Heron's formula, like to find out the area, to find out the coast, that's all. There is nothing more than that. Let's move to another example. Like I told you that it is also used to find out the area of quadrilateral. So how could we just find out the area of quadrilateral? We have to just add both the triangles. For example, A is equals to 3 centimeters, B is 4 and C is 5. Now S will be equals to 6. Am I right? Now what will be the area? That will be 6, 3, 4, 1. Right, this will be something. So 3 to 3 multiplied by 2, 3 to just 6, 6 6 36, so it will be 6. So 6 centimeter square will be the area of the first triangle. There are two triangles, you can see in this given figure. There are two triangles, this is ADC and this is ABC. So the area of triangle ABC is equals to 6 centimeter square using Heron's formula. Now what you have to do is we have to find out the area of triangle ACD. For that, calculate S again. 5 plus 5, 10 plus 4, 14 by 2 is 7. So let's just put in the formula. 7 minus 5 is 2. 7 minus 5 is 2. 7 minus 4 is 3. Right. Now 3 2 2 is 4, 3 12 into 7. So that is 84, I guess. So by this we can just find out, like it will be 2 root 21 centimeter squares. Okay, so we can just write it down as that the area of triangle ACD is equals to 2 root 21 centimeter squares, or we can calculate it as 9.2. You can just put the value of root 21. Okay, now the area of the quadrilateral will be equals to the addition of both the triangles, that is 6 plus 9.2, and you will be getting 15.2 centimeter square as the final answer. Okay, so this is the area of the quadrilateral equals to 15.2 centimeter squares. So basically what is important in this mensuration unit is to just write down all the units correctly. People generally make mistake, they find out the correct answer but they form the wrong very wrong units, and due to this they lose their marks. So what you have to do is you just have to mention the correct unit always. If there is some unit conversion, do the unit conversion too. You can't just use the two units in this single numerical. You have to convert one of the unit to like go through your numerical or like to get the correct answer. So this is about the Heron's formula. Okay, so Heron's formula is that much only. You just have to know that what is Heron's formula. You must know that the formula of Heron's formula is root over S multiplied by S minus A, S minus B, S minus C. Okay, where S is equals to perimeter divided by 2, or we can say that A, B, C are the sides of triangle, and S is equals to A plus B plus C by 2, or the perimeter divided by 2. Now you just have to know the values of all the side. You can calculate the S by finding out perimeter and dividing by 2, and then you have to just put the value in the formula, that is root over S, S minus A, S minus B, S minus C. Remember, S is the half of perimeter and A, B, C are the subsequent sides of the given triangle. Okay, so this is about the Heron's formula. It is like this only. In this chapter you will just have to like calculate the area of triangles, calculate the area of quadrilaterals, okay, and all those figures which include triangle in their formation, that will be calculated by using this. So you can also, like I explained you, in the daily life you can use this Heron's formula. Like for example, for the triangular, something which is triangular, you can just calculate by using Heron's formula. You don't need to have height, you don't need to have base, because in the cases of like finding out the area, we always know that the convention formula for finding out the area of any triangle is always half into base into height. So for that, it is not always like compulsory that height or altitude of the triangle is given. So for that, you always have to calculate the triangle's altitude by drawing the imaginary altitude and considering the right triangle and so on. So you can just do that by simply knowing the sides. You don't have to calculate these altitudes and all. So you can just put the values in the given formula and you will be getting your Heron's formula and the area of the triangle. So beware of the units. You just have to be more careful with the units. You have to practice the question. In case of any doubts and queries, you can just comment below, and me and my team will be there to help you people, and we'll reach you like anytime. Okay, now I'll just begin with the next chapter of the unit number 5, mensuration, that is surface area and volume. I know a bit of the people scared from this particular unit, okay, or this particular chapter, because there are lots of formulas in this particular chapter. But trust me, if you get to know some of the formulas of this particular chapter, then you will be able to solve the questions, or like know that what is the surface area and volume actually means. Okay, so let's just start with the next chapter. So let's jump to the next chapter, chapter number 13, that is surface area and volumes, right? So basically the question arises, what is surface area and what is the volume? I am sure that in your previous classes, in your earlier classes, in earlier standards, you must know about the surface areas and the volume term. Maybe surface area you are not aware of, but the volume you must be aware of, that what is the volume of something, right? So in this particular chapter, we will witness certain shapes like cubes, cuboids, cone, a right circular cylinder, a sphere, and the hemisphere. These are the some shapes which we will be going to discuss in this particular chapter, and I will show you that what is a cube, what is a cuboid, and what are all these shapes and what are the properties of these shapes. These are basically the 3D shapes. These are the three-dimensional shapes, and you have to know about the volume, surface areas, and surface areas could be of two type. Let me tell you, that could be a total surface area, and the another type is lateral surface area, or you can call it curved surface area. As the name suggests, let me tell you what is this total surface area, what is this lateral surface area. Basically, a total surface area is something which includes all the parts. Let's just suppose this is a cube. Let's just suppose how we are going to draw the cube, like this. Okay, so all the parts which include all the faces of this cube, that is the total surface area, right? What is the lateral surface area? Means area of the curve or four walls. Like in this particular cube, let's just suppose this is a particular cube. In that particular cube, only this particular wall, this particular wall, this particular wall, right, and this particular wall. So these four walls except roof and floor is known as the curved surface or lateral surface area. Except roof and the floor, that is known as the curved surface area, except this roof and except this floor. In the case of figures like cylinder, curved surface area will be the surface area of this particular curve, except bases. The upward and the downward bases of cylinder won't be counted in the curved surface area. Now in case of cone, this will be the curved surface area. This won't be counted, right? So let's discuss some shapes and I will tell you that what are actually the curve and lateral surface area is. I hope you people got the idea about the surface area thing, right? So first we are going to discuss about the cube. What is a cube, right? A cube is basically a 3D structure. In the earlier standards we're going to make the cube like this. Okay, now we know that what is the edge is basically the sides, vertices is basically these corners that are called vertices, and this is the square face, because in case of cube there are total 6. You can consider a cubic room. Okay, let's just consider a cubic room, like the room in which you are sitting right now. It consists of the 4 walls, right? It consists of the 4 walls. It consists of a ceiling, and it consists of the floor, right? So it comprises of 6 square faces. In case of cube, all these square faces are equal, right? There are total 12 edges and 8 vertices in case of cube. Here is mentioned the surface area of the cube, that is 6 multiplied by b square. B is the length of the edge. Basically the cube has equal edges. You know that cube has equal edges, right? So that is why in case of cube, 6a square will be the surface area of the cube, and the volume of the cube is basically b cube. B is the length of the edge, right? Now let's move forward towards cuboid. This is a cuboid. You can just consider a matchbox, like when we just overlap the two cuboids or two rectangles like this, then it forms a cuboid. For example, a matchbox is a cuboid, right? Okay, so in this case also, this is the face, this is these corners are vertices, this length is edge, right? It has 6 faces. Like cuboid is also a kind of the room, but it has no, all the faces are not square. In this case there are 12 edges and there are 8 vertices. They are both are same, but in that case all the faces are equal to each other, and in that case all the faces are not equal to each other, right? So the surface area of the cube is 2lb plus 2bh plus 2hl. What does that mean is L is for length, B is for breadth, and H is for height, right? And the volume of the cube is L into B into H, that is length into breadth into height, right? This is about the cube and cuboids. Let's move forward towards the other shapes or 3D shapes, that is cone and a cylinder, right? This is a cone. I'm sorry, the first is the right circular cylinder and the second one is the cone, right? So here we'll discuss that what is a cylinder. Basically you know that this is the shape of a cylinder. It is also the shape of a pipe. This is the curved surface area. These are the circular bases of the cylinder. So basically the cylinders, you don't have to just know about these right, oblique or truncated cylinders. These are not for your purpose. You just have to know about what is cylinder. Okay, you know the figure of cylinder. You know that there is basically 2 types of bases. These are circular bases, and you know that this curved portion is the curved surface area. So the total surface area of cube cylinder is 2 pi rh plus 2 pi r square. Why this 2 pi r square? Can somebody tell me? Basically these are the circular bases, as I told you. These are the circular bases, right? So what will be area of these circular bases? You know that area of the circle is equals to pi r square. Since there are 2 bases, that is why 2 pi r square is the area of the 2 circular bases. Addition, this is the surface area of this curved portion. Okay, now let's get back to the cone. That this is the cone, right? This is something cone. This is also a circular base of the cone with the same area, that is pi r square. that is curved surface of the cone, and this is the vertex of the cone, right? So in this case, the surface area of the cone is pi r l plus pi r square. Okay, so what these terms means, pi is the constant value of 3.14 or 22 by 7, right? R is the radius term. What is this L? This is something new for you people. So L is the slant height. Probably this L will be given to you people, because to know the formula of the L you have to go to the class 10th, and that the formula of L is mentioned for you people. I am just writing the formula of the L for the sake of you people. You don't have to just learn it, just go through it. This is the formula of the L, and this is known as the slant height, and you will be going to understand what this L is in class 10th, right? So the volume of this particular cone is 1 by 3 pi r square h, where pi is the constant value, r is the radius, and h is the height of the cone, right? These are the same terms which we are going to use in sphere, in hemisphere. Okay, so you have to remember that what is r stand for, what is pi, what is h stands for, right? So our first is the about hemisphere and sphere, right? So what is the sphere and hemisphere? Basically they both are interlinked with each other. The sphere is like this. I'm drawing a circle here, but this sphere is something 3D. Like you can consider a ball as a sphere. You don't have to consider a cutout of circle as a sphere. A ball is considered as the sphere. So when you cut this ball, it will appear something like this. Am I right? I have not drawn it properly, but when you cut a ball, it will be appear something like this, the half of the ball. Like this you can see the sphere. This is called as hemisphere. When we cut the sphere into two different or equal parts, then it is known as the hemisphere, and this is the sphere, right? So you can just consider any hemisphere, like you can just consider the example of a bowl in the kitchen as the hemisphere. You can also consider certain other things like headphones, right? Like a bowl, anything. Okay, so sphere is a three-dimensional solid that is perfectly round. Okay, it's the same thing which we have discussed in the circle, that center point has similar locus to the ends or circumference. Okay, now the surface area of this sphere is 4 pi r square, right? Now I've told you that in the what is the total surface area and curved surface area. That total surface area is the total all the faces, whereas the curved surface area include only the curves. So in the case of sphere, you can see that there is no face, there is only one curve, and that particular curve, so there is no lateral surface area in case of sphere, right? And what is the volume of the sphere is 4 by 3 pi r cube, where we know that pi is 22 by 7 or 3.14, and r will be the radius of the sphere, right? Now I told you that when the sphere is cut into two equal parts, then it is called as hemisphere. So the formula will also be halved. Okay, so the curved surface area of a hemisphere is, CSA of hemisphere is 2 pi r square. Now why this total surface area is given? I told you that in case of sphere, no curved surface or no total surface, only one surface area exists. But why in the case of hemisphere both the surface area exist? Because in the case of hemisphere, when we cut this sphere into equal part, the base, this particular base forms, right? That is why there is a curve and the total surface area. Curve surface area will be 2 pi r square and total surface area will be 3 pi r square. Why is it so? Because 2 pi r square is this particular curve portion and this base portion is circular, so it will be equals to area of the circle, right? and area of circle is pi r square, so we will just add and we'll get 3 pi r square. Now the volume of the sphere is hemisphere is 2 by 3 pi r cube, where pi is the constant value, r is the radius of the hemisphere. In the case of hemisphere, let me just explain you one more thing, that in the case of hemisphere, just note it down, people. If you have got any notebook, you just have to note this down. This is very important information. In hemisphere, radius is always equals to height, because we know that in a sphere the radius is always equal. So when we cut them in equal parts, this will be the radius, this will also be the radius. That is why the radius will be equals to this particular height, right? Okay, it means this will be equals to this. This is the height and this is the radius, right? Now I'm just there is some summary of all the formulas. I told you there is some summary of the formulas I have told you, so you just have to go through them very carefully, that what is the lateral surface area of the particular given figure and what is the lateral surface area of the particular figure. You have to go through cube, cuboid, cone, cylinder, sphere and hemisphere. That's it. This is in our syllabus. Similarity with the surface area formulas, you have to go through these 6 figures only. You don't have to go through this prism and pyramid thing, right? This is not in your syllabus. You have to go through just these 6 shapes, right? So let me just tell you, lateral surface area in the case of cube is the area of the 4 walls, and that is 4a square. Right, now in the case of cuboid, it is 2HL plus B, where H is height, L is length, B is breadth. Now in case of cone, the curved surface area is pi r L, where L is the slant height of the cone, whose formula is L equals to root over r square plus h square, where r is the radius and h is the height. Right, in the case of cylinder, the curved surface area is 2 pi r h, where pi is the constant value, r is the radius of the base and h is the height of cylinder. Now in the case of hemisphere, the curved surface area is 4 pi r square, and where pi is the constant value and r is the radius. In the case of hemisphere, the lateral or curved surface area is 2 pi r square, where r is the radius and pi is the constant value. Okay, you just have to go through your own to this table. This is very important, and here the figures are also given, the name of the solids are given, the formulas are given, and even that what these terms in the formula used stand for, they are also given. So you just have to go through this table very carefully, and when you will just go through this table, you will be able to remind the formulas on your own, and by that it will be very easy for you people to just solve the questions, right? Now the surface area formula is, cube is basically the surface area of the cube is 6a square. Now the surface area of cuboid is 2 LB plus BH plus HL, where L is length, B is breadth and H is the height. The surface area of cone is pi r plus L, where pi is constant, r is radius and L is the slant height, right? Now the cylinder is 2 pi r plus h, where this pi is constant term, r is radius of the base and h is the height. Sphere, the total surface area and curved surface area are same, like I told you. That is why the total surface area is 4 pi r square, where r is the radius of the base, and in case of hemisphere, the total surface area is 3 pi r square. What you have to do, you just have to learn this table, go through this table. This table is very important, right? So you just have to go through this table and just make sure that you can just learn this table, right? If you learn this table, then you will be able to solve each and every question of chapter number 13, right? Now our next slide is the volume of the shapes. Okay, so here I have given the volume of certain shapes. So what is mentioned in our basically in our syllabus is all of them. You also have to add another thing, that is hemisphere, which is not mentioned here. The formula for hemisphere, I'll just write it again. You just have to mention the another solid here, and the another solid is hemisphere, right? This is the hemisphere. The formula is 2 by 3 pi r cube, and in that formula r is equals to the radius of the base. Am I right? This is the hemisphere. Okay, so basically how does the hemisphere look? It look like this, like a bowl. Okay, it look like this. This is the r. Right, now the cube is basically this side is a. The formula of the volume is a cube, right? Because why it is a cube? Because all the sides are equal in case of cube, and a is the length of edge. Now rectangular prism, let me tell you that what is a rectangular prism stand for. Rectangular prism is something similar to, not similar, they are same, it is just the different name of cuboid, right? So you just have to know that what is rectangular prism. Why? Because in case if your examiner instead of cuboid uses the rectangular prism in the examination, then you people won't be able to recognize it. That is why just a note here that rectangular prism is the another name for the cuboid, and if any examiner mentioned the rectangular prism instead of cuboid, then you have to apply the formula for the cuboid, right? Now the formula for the cuboid is L into B into H, or L into W into H, where L is length, B is breadth, and H is the height. Now in the case of cylinder, it is pi r square h, where pi is constant value, r is radius, and h is height of the cylinder. In the case of cone, it is 1 by 3 pi r square h, where pi is constant, r is radius, and h is the height from this tip to this base, right? Now sphere, 4 by 3 pi r cube, where r is the radius of the base and pi is the constant value, right? Just remember these terms are common in everything. Radius, h is height, L is length in case of cuboid. In case of cube and cuboid, L is the length, right? And in case of cone, it is slant height. Just remember, if the cone's question is there, then you have to put L equals to slant height, and if the cuboid question is there, then you have to put it equal to the length. Now the hemisphere is basically 2 by 3 pi r cube, where r is the radius of the base, right? Let's move ahead with the certain questions I have prepared for you people. You just have to solve them on a, just don't look at the solutions, just try to solve these questions on your own, right? So our first question is, the two cubes each of volume 64 centimeter cube are joined end to end, find the total surface area of resulting cuboid. Now the volume of one cube is 64 centimeter cube, and it is equals to a cube, right? This is the formula. Then a will be equals to 4 centimeter on ton. Now the surface area of the resulting cuboid. What you have to do is just draw the two cubes like this. You can draw the two cubes. I just don't know how to draw them. Like this you can just draw them, and they will appear like this. This is something like this. So you know this length is 4, this length is also 4, this length is 4, this length is also 4, this is 4, and this is also 4. So in that particular case, if it forms a cuboid, then length will consecutively become equals to 4 plus 4, that is 8 centimeters. The breadth and the height will be equals to 4, and breadth will also be 4. Now you just have to apply the total surface area formula of the cuboid, that is 2LB plus BH plus HL. Am I right? Just have to solve this question out, and you will be getting this as your answer. That's all with the question. Now the next question is, a right triangle ABC with sides 5 centimeter 12 centimeter and 13 centimeter is evolved about the side 12 centimeter. This is the side of the right triangle, this is the height. So basically 5 centimeter is the side and 12 is the side and 13 is the side. Find the volume of this cone. We have to find the volume of the cone, right? We know that this the height is basically the altitude, so the height of the particular cone is 12 centimeter. Okay, now we have to know the radius. This is the particular radius and this side is 5, so r will be considered as 5. The formula for the volume of cone is something like this. Now just put the values. 1 by 3, 22 by 7, let it just be pi. R is 5 cross 5 by 12. Just cancel them out. 100 pi centimeter square will be the answer of this particular question, right? Let's move forward towards another question, that is question for the cylinder, right? Now a patient in the hospital is given soup daily in a cylindrical bowl of diameter. The diameter is given, so we can calculate the radius, that is 3.5 centimeters by halving the diameter. If the bowl is filled with the soup to the height is given as 4 centimeters. How much soup the hospital has to prepare daily to serve 250 patients? So basically, when we have to find out that how much liquid is present in a particular shape, how much liquid, how much sand, how much soil is present, then the volume of the liquid or the container is find out. So we have to find out the volume. That is clear. Why we have to find out the volume? Because they are talking about the soup. They are talking about the volume of certain liquid. A liquid cannot have any surface area. It has always the volume. So we can just find out the volume of cylinder by applying the formula, that is pi r square h. Right, now pi is basically 22 by 7 cross 3.5 by and multiply by 4, right? So we can just cancel like this. What we get is 154 centimeters cube. In the case of volume, the unit used is centimeter cube or meter cube. In the case of areas, the unit used is meter square or centimeter square, right? This is, I hope this is clear to all of you. Right, now this is the volume of the soup present in only 1 cup. Okay, now you have to just serve this soup to 250 patients. So for one patient, by unitary method, one patient 154 centimeter cube soup is used. So for 250 patients, what we'll do is, when we have to find out more than one, then we just multiplied the two terms, and we are getting here is 38500 centimeter cubes. Right, now we have to find out how much soup the hospital has to prepare, so the volume of unit can be in liters too, right? So what have to be converted in liters? 1 liter is 1000 centimeter cubes. Similarly, 1 centimeter cube will be 1 by 1000 liters. Am I right? So by this, 38500 centimeter cube will be equals to 38500 by 1000 equals to 38.5 liters. So they have to prepare approximately 38.5 liters of soup to serve 250 patients daily. Let's move to our another question. Okay, these are the questions related to the hemisphere and sphere. I just try to cover all these shapes, okay, by these questions. So find the total surface of hemisphere of the radius of hemisphere is 10 centimeter. Now what is the total surface area of hemisphere is 3 pi r square. In this question it is mentioned to use 3.14 as pi. So the volume, the TSA of hemisphere is 3.14 multiplied by 3 multiplied by 10 into 10, right? You can just cancel them out and you will be getting 942 centimeter square as your answer, right? Now let's move to the another one. Volume of the sphere whose surface area is given. Now how to convert how to know the volume when surface area is given. So this is very easy question. What you have to do is, with the help of surface area, just find out the radius of the sphere, and by using the radius find out the volume of sphere. So let me just tell you that the surface area of the sphere is 4 pi r square. It will be equal to 154, right? So what we'll do is, we just have to put the values here. We know r square is not given, so r square will be somewhat equal to 154 into 7 by 4 cross 22. This will be like 7, and it will be 49 by 4, or it can be 7 by 2, right? 3.5 centimeter is the r for the given question. Now the volume of sphere. You know the volume of sphere is 4 by 3 pi r cube. Just put the values. 4 by 3 pi. Now r cube is 7 by 2, 7 by 2 and 7 by 2. Cancel out them. You will be getting 179.67 centimeter cube as the volume of the given sphere, right? Now let's move to our next slide, that is our last slide for this chapter or this unit, mensurations. Okay, so basically it is a summary for you people, it is a glossary for you people to learn and revise the formula genuinely. You just have to revise and learn the formula, and then you will be all set to do all the questions. I have mentioned all the 6 shapes here, that is in your syllabus. In the cube is volume is L, B, H, or L into B into H. This lateral or curved surface area is 2LH plus 2BH plus 2HL. Okay, this is the lateral curved surface area, and total is 2LB plus 2BH plus 2HL. In the case of cube, the volume is A cube, the lateral curved surface area is 4A square, the total surface area is 6A square. In the case of cylinder, the volume is pi r square h, the lateral curved surface is 2 pi r h, and total surface area is 2 pi r plus h. For the right circular cone, the volume is 1 by 3 pi r square h, and the curved surface area is pi r l, and the total surface area is pi r plus l. For the sphere, the volume is 4 by 3 pi r cube, the lateral or curved surface and the total surface area both are same, that is 4 pi r square. In case of hemisphere, the volume is 2 by 3 pi r cube, the lateral surface area is 2 pi r square, and the curved surface area is 3 pi r square. So let me just write here, A will be the length of the cube, the length of the edge of cube, L is length, B is breadth. Why I am writing this again and again? Because the number of times I'll write this thing, you will be able to retain this thing. Okay, it will be retained in your mind. So that is why I'm just writing this again and again, that what is this R, what is this H, so that you people won't forget. Just remember that L in case of cuboid is length, and L in the case of cone is slant height, right? Just remember this thing. This is very important. Don't just get confused. And pi is as usual the constant term, or we can just mention pi as 22 by 7 or 3.14 is the value of the pi. Or if in any question the value of the pi is given, that you have to use that particular value of the pi, then just use that particular value of the pi in that particular question. Okay, so that's all with this unit number 5, that is mensuration. I hope you people could learn that what is a mensuration, how we can solve the questions of mensuration, the importance of units, the importance of formulas, the importance of structures and shapes, importance of Heron's formula, area, perimeter, volume, Okay, so this is all about the mensurations. I hope you people enjoyed. So in case of any doubts and queries, you can just leave a comment below and me and my team will get back to you. Okay, so thank you. Have a lovely